like to introduce Rob Beverly, who will be presenting IP Neo-colonialism, Geo-auditing RIR address registrations. Rob leads the Center for Measurement and Analysis of Network Data, CMAND, lab in Monterey, California. Rob last presented the Spoofer project at NANOG 34 nearly 2 decades ago and is pleased to be back with the NANOG community today. Oh.
All right, cool. Thanks, everyone. I'd like to talk about RIR address registrations and geo-auditing. So let me just start with the what and the why and try to set some context here. I think everyone in this room is familiar with the RIRs, the Regional Internet Registries. Of course, IANA takes big chunks of address, contiguous IP address blocks, and gives it to the RIRs to subsequently delegate. Of course, there's 5 of these RIRs. We're here in North America, and we heard earlier today from Aaron. I think it's interesting to look at the role of RIRs. This is taken directly from Aaron's Number Resource Policy Manual. The quote is, "The primary role of RIRs is to manage and distribute public internet address space within their respective regions." So there is this sort of inherent notion of regional service, right? We can also look at things like RFC 7020, which talks about the goals, the explicit goals of internet number registries. And one of the things they mention really has to do with accuracy. So a core requirement is to maintain a registry of allocations to provide accurate registration information of those allocations in order to meet a variety of operational requirements. So our work, which I'm going to go through in this talk, is, and I'll expand on each of these in turn. The first thing that we wanted to do was we wanted to look at the IPv4 address registry information across all 5 of the RIRs. Then we're going to use some of our measurement-based techniques to try to figure out physically where these addresses are actually being originated, where they're in use. We then develop a taxonomy of what we call geo-consistency, the registration geo-consistency. And this is going to look at how the physical location actually compares to the registration information and the RIR's region. And then last, we're going to apply this whole mess to doing an audit across RIRs and prefixes and get a sense of how they actually compare. So one of the first things you might be saying is, wait, Rob, what the heck are you talking about? Out of region use is allowed, right? And I think my first response to that is, it's complicated, right? Different RIRs actually have different policies, which I'll talk about in just 1 minute. The other thing I want to emphasize here is that, in this work, we are not looking at inter-RIR transfers. This is, a common thing that happens. A chunk of address space will move from one RIR to another. Those are publicly logged and vetted. And of course, other researchers have examined these and looked at these actual transfers in some detail. Instead, what we're really looking at is out-of-region use that can only be uncovered through some of this active measurement that we're doing. Also, we're going to adopt a fairly conservative view of what it means to be out of region, and I'll talk about that in some more detail in a bit as well. So to give you a sense of how it's complicated, the NRO has what they call the Comparative Policy Overview. I'm sure many folks have seen this, but I've extracted a couple of salient points from here. For Aaron, for example, to receive resources, Aaron requests organizations to verify that they plan on using the resources within the Aaron region. We might contrast this with APNIC. APNIC is very loose in a sense. As long as you have an account, if you are an account holder within the APNIC service region, you can use APNIC delegated resources anywhere, including out of region. So they're quite explicit that that is actually allowed. At the other end of the spectrum, we have AFRINIC. And AFRINIC is probably the most rigorous policy, where they actually say they require organizations to both be legally present, as well as the infrastructure from which the services originate need to be located in the AFRINIC service region. So I think one of the things to keep in mind here is that there is quite a bit of variation currently across the different RIRs. So our motivation for this work was really to increase transparency and try to help the community understand where a scarce resource is being used. We wanted to quantify the extent to which the registry information is accurate and can meet some of these operational needs. And then we wanted to inform some of the what I would call ongoing discussions over what it means to have in-region address use and policy. And some of these are real discussions and important discussions. I would just highlight a couple of public news articles that had to do with ways that various organizations were either really or perhaps perceived to be taking advantage of the different registries and trying to benefit in some way. I also want to sort of try to be clear about what this talk is not. We certainly recognize that IP addresses are an economic resource. They have intrinsic value. And there's, of course, a need for efficient and equitable use of IP addresses. And also, recognize in talking to folks that there's real operational expediency that dictates how some of this happens. The real world is messy, so on and so forth. So again, the goal here is to shed some more rigorous light on what's going on with the IP address registration geoconsistency. We're not trying to claim that we're finding policy violations and certainly not advocating for policy changes. And I'm going to grab some water. So how are we doing this? Let me just start. I think most folks have seen examples of the information in the registries. Here is an example from ARIN. This is actually 2 records within an ARIN database. This is a /24 that's within a /8 that's allocated to ARIN. The organization in this case that corresponds to this /24 is actually an organization with an address in Brazil, right? Now you may note that, of course, Brazil is outside of ARIN's region. So we might ask, okay, well, this is interesting. Where is this /24 physically? And there's a couple of different answers to that question, right? It could be the case that this /24 is physically advertised in ARIN's region. It could be in LACNIC's region, i.e. corresponding to Brazil, or it might be in neither ARIN nor LACNIC, which would also be interesting. So remember earlier I said we were taking a fairly conservative view on what it means to be out of region. So in this case, we would basically say, okay, well, if we did find that this /24 was physically in the ARIN region, that's okay. If it's in the LACNIC region, that's okay too, because it corresponds to the actual organization that has registered this. If it's in neither the ARIN nor the LACNIC region, this is something we would label as inconsistent or something that might be worthy of further investigation. So as I said, we developed a taxonomy, and it's based really on 3 different values. So we have this RIR, for which the prefix is registered, so whichever RIR holds this prefix. Of course, there is the organization that is responsible for this prefix, and they will be in a particular region that has a particular RIR. And then finally, we're going to have this third variable, which is the geolocation. So when we do geolocate this, to what region are we geolocating it to? And with that, we can then, with these 3 different values, we can compare those and come up with 5 different outcomes. And these outcomes represent sort of the spectrum of consistency. So as an example, as the most consistent, we call this fully geoconsistent. This would be an instance where the prefix was contained within, say, the ARIN registry. The organization that registered it is also in the ARIN region. And when we geolocate it, it's also clear that it's in the ARIN region. At the other end of the spectrum would be something we would call fully geo-inconsistent. An example of that would be, as I was sort of pointing to earlier, there might be a prefix that's in the ARIN region. The organization, however, corresponding to that might be in, say, the RIPE region. But then when we geolocate it, it's geolocating to Japan, for instance. And this is, again, what we would call fully inconsistent. And there's a range of intermediate consistencies. So here's the high level of our methodology. In the next few slides, I'll go through sort of the nitty-gritty of each of these. But we start with the bulk Whois records from each of the 5 RIRs. We suck those in, throw them in a database, parse them, so on and so forth. The next step is we use a hit list to try to identify targets within each prefix that we can measure to. We use these two to drive a probing logic, and then the probing logic actually instructs the RIPE Atlas measurement infrastructure to issue probes. If you're not familiar with RIPE Atlas, this is a service out of RIPE. It has about 43,000 different nodes across the world that can do sort of primitive measurements, things like pings and so on and so forth. So using that probing logic, we're going to do a whole bunch of pinging, in essence, get a bunch of RTTs. That will all go into the database. Then we have an inference algorithm that allows us to identify the region, or the RIR, that is the most likely geolocation for that prefix. And that allows us to then come up with this per prefix RIR consistency. So let me just run through each of those steps in turn, because I think there's some interesting points. The first is, of course, when we suck in those bulk Whois records, the format, there's idiosyncrasies in each of these RIR databases, right? The key value pairs are different, the way things are mapped are different. In many cases, we have to be careful to ignore certain things. We have to ignore records that are clearly transferred. In some cases, there's records in the database that say this is just a placeholder. An example would be at the bottom where it says this is a record in the RIPE database, but it's a non-RIR managed address block. So we skip all of that. We then, of course, parse out of this the organization's country and map the country then to the RIR responsible for that country. So in that very first step of ingesting all of the bulk Whois data, that gives us our first 2 values, right? The RIR to which the prefix belongs and the RIR of the corresponding organization. So here's, before we do any measurements, right, just looking at the bulk Whois data, we can see a few interesting things. First of all, to give you a sense of scale, if you've never looked at the bulk Whois, there's about 8 million prefixes in there. Across the 5 RIRs. That, of course, is a much finer granularity than, say, the BGP. And for ARIN, for example, there's about 3 million of these prefixes, and about 2.5% of those have organizations with an address that's out of region. By contrast, if you look at Afrinic, fully 14% of those records for Afrinic actually have addresses that are out of region. So, one of the points here is that this inter-RIR region registration thing, it's not uncommon, right? It happens. In fact, it may be explicitly allowed. Again, quoting from ARIN's policy manual, registered resources may be used outside of the ARIN service region, provided that the applicant has a real and substantial connection to the ARIN region, right? So if we actually just look at the bulk Whois data and say, okay, for these instances where we have out-of-region organizations, how do these things map? For instance, there's a lot of ARIN prefixes that actually have organizations responsible in AP-NIC region or the RIPE region. Conversely, for RIPE going to ARIN. When we look at Afrinic, that 21% here what we're seeing is that the majority of those are actually organizations that have addresses in Afrinic, but the registered organization is in Asia, for example, and second in the ARIN region. So the next part of the methodology is to say, okay, let's dive into this actual geolocation aspect of it. And so the first thing that we need to do then is to have targets that are responsive within each prefix. For this, we utilize a well-known hit list that has a database of likely responsive v4 addresses. We do the longest prefix matching to make sure that we're mapping those to the correct prefix. And there's some other magic in there, right? We have to, for instance, ignore any cast. Any cast is going to, of course, not give us reasonable results. And from this, we randomly sample 10,000 non-anycast prefixes that have responsive targets from each RIR. And we did that on purpose because we wanted to have an equal number of prefixes, of samples, in essence, represented across each of the RIRs. In the third step, we do the delay-based IP geolocation. To do this, we're actually going to use 20 ripe atlas nodes in total. We select the atlas nodes as follows. So we choose 3 nodes within each of the RIR regions. For that, that means there's 5 RIRs. So we'll have a total of 15 different vantage points. And then we choose an additional 5 vantage points, ripe atlas nodes within the registered country for that prefix. And there's some more details, but in essence, what's happening is we're going to figure out which is the most likely RIR geolocation based on which of these vantage points gives us the minimum RTT, the minimum round trip time from doing this pinging. So of course, there's a bunch of limitations here, and this is true with any measurement-based approach. We're doing an inference, right? So first of all, there may be some bias in the prefixes that we select. So we do randomly select the prefixes, but we're only looking at 10K. Again, we did that on purpose to have an equal number of samples. We're currently doing additional probing, as you might imagine, to basically map all of the prefixes. It may be the case that there's no atlas probes within the registered country for that prefix. This does not happen often. Ripe Atlas has really good coverage, as I mentioned, 43,000 nodes, covering about 87% of all countries. Of course, the location of the atlas nodes may be incorrect. This can also happen, but you'll note that we try to minimize any error due to these kinds of things. So for instance, we have 5 different nodes within each country, 3 different nodes within each continent, and we're doing a bunch of consistency, normalization across those measurements to ensure that we're not getting bad data there. It can also be the case, of course, that the registered country for this prefix, it might be a corporate headquarters that's somewhere else. And I think the point here is that we're using this as part of our conservative notion of out of region, right? So all of this work could be done completely ignoring this notion of where the registered country is. This is just all about the accuracy of the registration and having a second chance to be consistent, right? That's why we have this other notion of, is it at least consistent with the organization's registered information? And then finally, there could, for instance, be inconsistent prefixes. So you might imagine that there's some subnetting. A prefix might have part of its part of this prefix might be allocated to one particular continent and part to another continent, in which case it would be inconsistent. We're doing additional work to essentially look at this phenomenon to see if there's multiple, by finding multiple targets within a prefix and ensuring that it's consistent. The other thing that we get asked sometimes is, why are you doing this latency-based geolocation approach? For instance, there's things like geolocation databases. In the research community, one of the ones that's very popular is MaxMind. That's because it's free and public. First of all, those are known to contain inaccuracies, and in many cases, there's evidence that they're using the Whois itself to build that database. So it doesn't make a lot of sense to use that if, in fact, it's just inheriting errors from the Whois, right? That's what we're trying to figure out. Also, if we talk about looking at the BGP or looking at AS origin information, as you all well know as network engineers, that can drastically obscure the true location of these addresses. So using latency-based geolocation, it has some nice properties. One is that, of course, it relies on the physical signal propagation and speed of light type constraints. And yes, of course, that latency-based geolocation can be inaccurate, but at the granularity of, say, RIRs, continents, things like that, it's highly accurate. It's hard to fake the speed of light here, right? So so that's why we're using it. Furthermore, and not contained in this talk, but in the paper, we have a second set of measurements that we do if we do have sort of an inconsistent result. And so we have a refinement round to make sure that our inferences are correct. Okay. I think I skipped a slide. So let's talk about some results. Let's get to some of the more interesting bits here. So I think, it's interesting. I always like to do examples. It's always fun. So here's a case study, right? So there is a prefix in RIPE. It's a /16, and it's a big CDN, okay? It has an organization address in the UK, so this seems, reasonable, right? It's in the RIPE region. The organization's address is in the UK. So let's take a look at what the methodology does, right? So the first thing that it does is, since the organization is listed as being in the UK, it finds 5 RIPE Atlas measurement nodes also within the UK. The results of that, it turned out, the minimum across all of the measurements by all of those 5 nodes within the UK, the minimum of all of those was an RTT of 129 milliseconds, which is pretty high, very high for a very small country that's pretty well connected. So the next bit of this, of course, and I don't display all the measurements on this slide, but of course, we're going to have measurements from the other regions, right? So if we look at the Atlas nodes that are in the RIPE region in Europe, so this, I think in this case, it chose a node in France and a node in Germany. If we look at the minimum RTT across all of those measurements, it was even higher. It was 149 milliseconds. Measurements were then done from the African continent, and those measurements were even higher. Those were, about a quarter of a second, indeed, as the minimum RTT to this target. However, for the Atlas nodes that were in the ARIN region, the minimum RTT actually turned out to be 71 milliseconds. And then through some rounds of refinement, it turns out that there's an Atlas node that's in Phoenix, Arizona that has a 7 millisecond RTT to this particular target. And it's almost certainly the case that this particular prefix is being used to number resources in a Phoenix data center. So this is an example of a RIPE registered prefix that's registered to an organization in the RIPE region, but is actually physically being used in the ARIN, in the United States, in ARIN's location. So this is in our taxonomy what we would actually call registry geo-inconsistent. Okay, so I said that we did this across 10,000 prefixes for all of the different RIRs. Here's the results. You can see that there's variation among the different RIRs. It turns out RIPE and APNIC are actually the most consistent. And I think this is an important takeaway from this slide. So this is a stacked bar chart that the y-axis starts at 50%. So that's just to actually see what's going on here. The important thing to take away is that we're doing really well. About 96% of all of the prefixes are fully consistent, right? So that's a good takeaway. The second takeaway from that is what that means is that, yes, there is a small number of inconsistent prefixes, but it's a small number. It implies that we could, for instance, manually investigate those or more deeply investigate those. So that's certainly something that we think is an area for the RIRs to actually look into if it's something that's of interest to them. When we look at the different kinds of inconsistencies, we do see that Afrinic has the most inconsistencies of any of the RIRs. And the most prevalent type of inconsistency is this registry geo-inconsistency. The example that I just gave before, where the RIR is Afrinic, the organization is in the African region, but those addresses are being used outside of Africa. Since we're at NANOG and we're in North America, I think it's interesting to talk about ARIN just a bit. ARIN has almost 95% of the prefixes are fully geoconsistent. We also, again, have this consistency category country geoconsistent, which is another 1%. There is some inconsistency, so what's going on there? The primary contributor there are prefixes that seem to geolocate to Mexico, and about 50% of all of the LACNIC inconsistencies are prefixes that geolocate in US. And so that kind of makes sense, right? Just based on the relationship between North and South America. When we look at Afrinic in some more detail, the registry geo-inconsistencies are really dominated by instances of inconsistencies due to the addresses being used in Europe and in China. So takeaways. Okay, so the first takeaway, of course, is, again, different RIRs have different out-of-region and address use policies, but so far there's sort of been limited visibility on where the resources are used, especially post-allocation. So from chatting with some RIRs, I've kind of learned that there's a fair amount of vetting initially, but perhaps less after the allocation is made. The allocations are largely geo-consistent, which is good news, but with some notable exceptions. I think it's an interesting discussion about how these inconsistencies raise operational and security concerns, and how we should think about updating registration information. Finally, the RIR Whois records, the bulk Whois records, do use very inconsistent schemas. It does make it hard for folks like me to analyze and work with the data. I'm told that things like RDAP will hopefully fix this in the not so near future. So thanks a lot. If this is something you're interested in and you want to beat me up on technical details, there is a draft academic paper up on archive. That's the URL. I would also mention that one cool thing about the RIPE Atlas platform is that all of the data measurements are open and public for transparency. And so, in fact, all of my measurements are tagged, and so you can look at those for reproducibility. This work is the first quantitative geo-audit of RIR IP address registries. In the future, we're going to do things like expanding the measurements, as I referenced. We're looking right now at some of the relationships between the age of the prefix, which is not always easy because we don't always some of the registries don't have that information. The size of the prefix, consistency, extend this to V6, and we're engaging with the different RIRs, and certainly welcome any feedback or flames. So thanks a lot.
Hi, Rob. John Sweeting, Chief Customer Officer with ARIN.
Hi.
So you mentioned that you go to IANA to find out where the /8s are supposed to be.
Well, so in essence, I rely on the bulk Whois data as the authoritative record.
Okay, because some of the /8s are shared. There's a few of them that were shared with early transfer, and that kind of makes sense with the Mexico thing and ARIN, because the records, we were servicing, ARIN serviced Mexico prior to LACNIC being stood up. So those /8s have been split up, and some belong to LACNIC, some are managed by ARIN, and it's hard to tell which is which.
So I think I got that right, but I would love to share some of the results with you to make sure it's right.
I'd love to talk to you about it. There's one other thing. The record you showed for ARIN was actually a reassignment record.
Okay.
You can tell by the org ID. If the org ID starts with a C, it means customer, and it's a reassignment from whoever we gave the addresses to. They have a customer out of their region that they have given space to.
For sure.
So there's some things like that. So yeah, we'd love to talk to you and answer any of the questions you have and help you get the data 100. It looks really good. It looks like you've got a lot of the stuff covered, but I'm sure there's a few idiosyncrasies that you have missed. And it's not your fault.
No, I mean, this has, of course, had a long history. I would welcome that and welcome the opportunity to do that and make sure, this is initial work, and part of the reason I'm here is to build these relationships.
I was actually pretty happy with the results, 94% like that.
Cool.
Makes sense.
Thank you.
No questions from the online audience yet.
Hi.
Hi, Scott Johnson, AS32639. I'm curious that it seems as the majority, or at least the largest percentage of IP addresses that have moved from regions are coming from AFRIDIC. Do you have data on which ASs are announcing those prefixes?
I have not looked at that. Frankly, I'm trying not to name and shame or anything like that. I'm trying to step clear of those waters. Again, the data is public, and I would love to engage with folks. Send me an email. I have not looked at that.
Thank you.
Hi, Michael Costello with DriveNets.
Hi.
You said in an earlier slide that you did not want to use geo-IP because of inaccuracies in it. I'm wondering if you took this data and then also that you found actually did look at geo-IP data and then saw what the discrepancy was between it.
I have a student looking at that.
Okay.
So yes, we thought about that, and we're looking at it right now. It's a great suggestion.
Thanks.
Perfect. Thanks so much.